Views and news with Clarence Ford.
Share your perspective.
Only on Cape Talk.
It is 9:36 on this Friday morning, and a very warm welcome back. At 9:30, just after that news headlines, we have a date. We have a date with the Naked Scientist. So he joins us from London via Zoom. The Naked Scientist, Dr. Chris Smith, lecturer at the University of Cambridge, here to answer your question. Good morning, Chris. Great to have you back.
Hi, Clarence. How are you?
I'm good. It's been chilly down south. Chilly and very rainy. So yeah, our dams are full. I think we should be chuffed about it. But some people are getting really cold.
Not the same here. We're having our summer today. And then it'll be back to winter again probably next week. No, seriously, we've got a little mini heat wave over the southern part of the country. So we're going to reach the dizzy heights of 30 over the next day or so. But that will be nice because it's been so dreadful. It's when people say the weather has been doing extreme things in recent years, they're not wrong, are they? Because in 2022 we saw the hottest temperatures that Britain had ever recorded, 40 degrees up the road from where I am in Cambridge in the Botanic Gardens on one day.
Wow.
Then last summer it wasn't really a summer, and this summer we're saying come back last summer because this is all forgiven because this is so terrible. And then you've got things like Hurricane Beryl raging its way across the Caribbean, a high-intensity storm much earlier in the storm season than we've usually seen them to crop up. We've also got an anticipated much greater increase in the number of those storms happening each year. So I think we've got more of the same to look forward to be perfectly honest, and we're all pointing the finger at a range of factors, including natural variation, but superimposed on climate change, which is going to certainly make the situation worse.
Yeah, and you've got Olympics across the channel. I would imagine that their weather's not really good then as well.
Yeah, that's true. The Olympics are kicking off, and it's not great for some sports if it's too hot or too wet. So in some parts of Europe, it's raining pretty hard. In other parts of Europe, it's very sunny and very, very hot. So I'm quite looking forward to it, actually. I do like the Olympics because I find myself looking at the Olympics scientifically, as well as thinking about the sporting prowess and the fun of watching it. It's also what's the science going on here, because you can look at the physiology of the athletes and think, well, how on earth are their bodies coping with that? You look at events like chucking things very hard or hurling yourself over very high barriers, and you try and work out, well, how much energy is that person actually burning off doing that? It's extraordinary.
Okay, let's get to the questions. Plenty via WhatsApp, voice notes in. Let's take a listen, Joe.
Chris, hi. Name's Linda from Cape Town. I would like to know what causes this terrible smell on linen, even in a cupboard, even after it has been washed and dried, and give it a few days and the whole cupboard starts smelling terrible.
So why does washing have that particular smell? Well, the answer is that usually it's because of mould. There are around us ubiquitously millions and millions of spores, which are effectively seeds of fungi. And some of them thrive in certain environments. They love damp places that are warm, but also dark. And if you think about your linen cupboard, if the linen is not perfectly dry when it gets in there, or linen being the way it is, it's going to soak up moisture from humid air. So it does become damp. It's therefore a food source and an environmental culture ground for microorganisms, particularly moulds. So a lot of these things, when they begin to grow and they form small colonies on surfaces and so on, they do produce a smell. And part of that smell is because in the same way as we burp and fart, they belch out various odours as they metabolize. They eat things in the environment. They can even eat the clothing itself. But also they release more of the spores that spawned them in the first place, and they too have a smell. And so I suspect that what's being referred to here is that dry linen, when it goes in the cupboard, quite quickly becomes slightly damp linen, especially if the cupboard itself is slightly damp, the atmosphere is slightly humid. Mould that's universally in the environment starts to grow on those surfaces, even in tiny amounts, and it releases various volatile chemicals and spores, which some people are probably very sensitive to the smell of those, and that's what gives it that characteristic odour.
Let's go to Zuki. She's in Big Bay. She's on the line. Go ahead, Zuki. We're listening.
Hi, Clarence. Hi, Dr. Chris. Since we started the show off talking about weather, I've got a related question. So on apps and stuff, you'll get the actual temperature forecast, and then there is the real field temperature. Why is there a difference in those two temperatures? How is it measured? Because I've seen the differences are sometimes more than 10 degrees. So surely what we feel is what the temperature is.
Yeah, this is referred to as wind chill. And what's going on when you are, say you're standing with no clothes on in a room, your body is losing heat to the air around your body. And that's because the air is colder than you are, and energy, or in fact anything in nature, moves from where there's an abundance or a surfeit of that thing to where there's less of that thing, so you equilibrate. And ultimately you'll end up with a situation where everything's shared equally everywhere. So all the time that you're hotter than the air around you, you're losing heat to the air around you. If the air's not moving very much though, as soon as you give the air some heat, the air now is warmer than it was, so the rate at which heat moves from you to the air slows down because there's less of a difference between the hot and the cold, so the flow is slower. If, on the other hand, I take the air that's just been warmed up by you away from you and put some of the original cold air right next to you again, that rate goes back up again because the difference between the cold air and you is now greater. So the rate of heat loss accelerates. So when you put a fan on yourself, the fan isn't actually cooling the room down at all. What the fan is doing is keeping the air that's going past you at the cold room temperature rather than allowing a cushion of air around you to get warmer and insulate you from the room. And that's the basis of the wind chill effect. You go outside and the cold wind wafting past you is whipping away any air that your skin has warmed up next to itself, and therefore accelerating the rate of heat loss down to the ambient conditions, so it makes it feel even colder than you were feeling before, albeit at the same temperature.
Then we have a question in: we humans are primates along with apes and monkeys in similar scientific classification. Why are humans able to grow long locks of scalp hair but not apes or monkeys?
Well, you could say, why is it that my head hair can grow down, if I was so inclined, to the bottom of my back? And some people do grow very long hair, but on the other hand, my eyelashes, thankfully, are only a matter of millimetres long. Other curly hairs we have on other bits of our body are somewhere in between. And the answer is, it all comes down to the genetic program that's running in the follicle, which is the structure that makes hair. And different genetic programs will dictate the different phases of those follicles, because hair follicles go through 3 phases. An anagen phase, similar to the word anabolic steroids. Hopefully no one's abusing those at the Olympics. These are growth, so therefore you have a growth phase, and while that's in action, the hair gets longer. Then you have a resting phase when the hair follicle stops and the hair falls out. And then you have a telogen phase when everything resets itself and then growth starts again. And if you vary the length of those different phases, you will get different length hairs. So the growth phase of a head hair is years, the growth phase of a pubic hair is weeks, and the growth phase of an eyelash is even fewer weeks. So it determines how long the hair can become. And so if you have an animal that has very long hair, the growth phase of its hair follicles are longer. If you have very short hair, it's shorter. And so apes will be running a genetic program that gives them hair that's relevant to them. An orang has quite long hair, for example, whereas a chimpanzee has some shorter hair. It's what has turned out by evolution to be in the best interest of that animal, balancing the metabolic cost of growing your hair, because hair is protein, it's costly to have, versus the defense and the warmth and camouflage effects of having that hair. And all those things are balanced out, and we've arrived at something that suits each individual species, giving it the best compromise and the best set of benefits for effectively the best bang for its buck in its environment.
Then we got a voice note in. Let's take a listen.
Good morning, Clarence and Dr. Smith. It's Jason here. What is the difference between a sprinter and a long-distance runner? I know they're physically different, but what makes the muscles react faster as a sprinter compared to a long-distance runner? What is the difference between the individuals and the athletes?
Hi, Jason.
Thank you.
This is an excellent and obviously very timely question, and the answer is they are worlds apart. Why is it, for instance, that the people who run in the London Marathon and do in 2 hours what it takes me about 3 times as long to achieve, why are they a certain physique? And what is it about them that means they're very good at that versus if you put them on a 100-metre track, then they're not going to beat Usain Bolt. They're not going to run the 100 metres in sub 10 seconds or sub 9 seconds. The answer is it comes down to how your muscles work biochemically. And people who are doing long distance, sustained exercise they have a very different muscle physiology and biochemistry compared to people that are doing fast, intense, anaerobic exercise. When a runner runs down the 100-meter track, their muscles are hardly using any oxygen. They are mainly operating during that extreme exercise anaerobically. And what that means is that they are using metabolic pathways that do not use oxygen to release energy from the sugar. It's chiefly sugar, glucose, that the muscle cells are exploiting for their energy supply. And what this does is to produce a huge amount of power, because the muscles that do this are so-called fast twitch muscles, don't have many blood vessels because they don't need to, because they don't use oxygen, but they liberate massive amounts of energy very, very quickly, producing huge amounts of force, which gives you enormous acceleration, but they're fast to fatigue. Because what happens is, when you use those energy sources to produce massive amounts of energy without oxygen, you have to do something with the waste products. And the waste products of that kind of metabolism are lactic acid. And lactic acid produces the burning, fatiguing, tired sensation in muscles when we do bouts of extreme severe exercise. And those people who are sprinters are mainly operating anaerobically, and they're building up what's called an oxygen debt. So by the time they get to the end of the track, whether that's 100, 200, even 800 metres is considered a sprint, isn't it? But when they get to the end of the track and the finishing line, they have built up a massive stockpile of waste products, chiefly lactic acid, other things like potassium, and these are then remetabolized elsewhere in the body to turn them back into useful things that can be turned back into sugar. But you will compensate for having produced them by producing or augmenting your respiratory rate. So if you watch someone who does this, they will then breathe at a ferocious rate afterwards, because you then pull in oxygen to metabolize those waste products and pay back that oxygen debt. Now, the long distance runners and the sustained performance athletes, on the other hand, they, by training, have shifted away from using anaerobic metabolism, and they have built muscle, which is what we call slow twitch muscle. It's got lots of blood vessels, it's got lots of myoglobin, a substance that's like hemoglobin in our blood and good at grabbing oxygen from the blood, and they have increased the enzymes in those muscles that are really good at using oxygen to convert sugars into energy. So they don't build up a huge oxygen debt in the same way as a sprinter would. They can carry on going for much longer without stopping. But the downside is muscles that operate that way tend to be a bit slower, and they tend to produce less severe, rapid bouts of power, but they're very good at running for long periods of time. And so when you train, what you're training into yourself when you're preparing for an event is you're pushing your muscle metabolism and biochemistry towards either a slow twitch or a fast twitch type of performance. And therefore, whether or not your athletics is based around building up an oxygen debt and then dealing with it or not.
Message in via WhatsApp. Hi, Dr. Chris. Why do Greenland sharks live so much longer than other sharks? That one from Logan in Edenvale, Johannesburg.
And in fact, scientists were shocked when they discovered how long these animals live for. And they did it by, when some of these animals were accidentally caught or corpses were found, they took the eyes from them. And because the proteins in the lenses of our eyes, you use the same eye lens throughout your life, you can't repair it, which is why we get cataracts and things. And so the proteins that are in there are the proteins you were born with. And so if you look at the, say, carbon fingerprint that's in there for radiocarbon dating, it must date from the time you were born, and you can therefore date yourself. And they did this on these sharks and were very shocked to find that they're hundreds of years old. And the answer is that things happen because nature has selected for things to operate the way they do. If there's an advantage to operating a certain way, then you will be selected by the environmental pressure to flourish and pass on your genes. So the fact they're very long-lived could have a range of benefits. One, they may need to be very big in order to survive and to reproduce efficiently. They may also need to be very big in order to sustain the sort of communities that they do, to exploit the environment that they do. So something will have given them advantage through longevity. So that will be selected for. The other question, I suppose, inherent to this is, well, why would an animal need to live that long anyway? And the answer is that it probably can, because the environment it lives in is very cold, and fish are cold-blooded. And although, because of their being enormous, they do tend to have quite a high core body temperature. If you look at a salmon shark in the Pacific, for example, they will have a core temperature which is 37 degrees, because they're so massive and they're metabolically active swimming along that their core is down at the same sort of temperature as us. But the peripheries of the fish may be very, very cold, 4 degrees or so. So these animals will have higher temperatures in their core but lower peripherally, and that low temperature and that lower metabolism endows them with longevity, because they don't clap themselves out through running a very fierce, ferocious metabolic rate like we do, because we're striving to maintain a hot temperature all the time, and that's metabolically very costly, and it produces lots of waste products that effectively age us, whereas fish don't have that problem, so they can live that long. And something in the way that the environment they interact with the environment has selected for them having the ability to exploit this fact and live for a very long time. And as I say, probably something to do with social structure, reproduction, predation, and so on.
The Naked Scientist, a big appointment on a Friday. Dr. Chris Smith with us. And take another voice note.
Clarence, môre man, Floris hierso van Worcester. And morning to Dr. Smith. Flies and ants, what are their position in the ecosystem, except for spoiling my chocolate stairs or ruining a nice plate of food? Yeah, I've always wondered why these creatures are with us and in our houses and around our houses or wherever we go. They are there, whether in a train or in a taxi. What are these guys' purpose in the ecosystem? Bye.
I would think of it the other way round, actually. I'd flip it round and say, instead of saying, why is this creature here? I would ask, or I would say, if you think about what nature is a whole raft of opportunities. Energy has arrived on the planet's surface from the sun, and it's powered plants, which are like nature's solar panels that convert the energy from the sun into chemicals that life can use. And so everything that exists because there is an opportunity to have a slice of that action, to exploit something, a supply of energy. Because at the end of the day, if there's no energy, we don't exist, and we can't live without food. Nothing lives without food. So the fact that there are animals out there argues that they are tapping into a food source that no one else is tapping into. So mosquitoes, for example, everyone says, why are they there? They're horrible things. Well, they are tapping into a food source. They tap into sugars and so on from rotting fruit, and occasionally they tap into us when the females need to reproduce. But they're also feeding other animals that eat insects. Ants are extremely good at recycling things. They ruin your patio and they'll get into your kitchen and dig holes in your cupboards and so on, but they're extremely good at recycling nutrients, and they will go and retrieve bird poo and so on, because there's loads of phosphorus in there, and they'll cart that off to their nest, feed their young, and in the process they're feeding other things that eat ants. Flies, extremely good at finding carrion and dead stuff and planting their maggots in there. The maggots eat through whatever they found, the dead corpse or whatever, and they secrete digestive juices to do so, and as they do so, they break it down. They're returning and recycling nutrients into nature and making energy available to other species, including bacterial and fungal and other things that will come along and eat the maggots of the flies. So it's very simplistic when you to think of life as just this species and this species. You've got to think of it in terms of a flow of energy, with plants at the bottom feeding successively more complicated animals higher and higher up this so-called pyramid of numbers, where as you go up each level, the complexity of the animals tends to increase and their number tends to decrease.
And I think we've got about a minute left for this question. Dr. Chris, can parrots see themselves in a mirror? Pat with that question.
They can certainly see themselves. Parrots have excellent eyesight and very, very good colour vision, and so they will definitely see themselves. They'll definitely see a bird. Whether or not they know it's them, this is a question. And parrots, in fact, are very intelligent, and it's perfectly possible that they will know that the bird in the mirror or the reflection is themselves. And people call this or refer to a theory of mind, the ability to sort of see yourself in your mind's eye, know it's you in the environment that you're looking at. Babies don't do this, but older children obviously do. Some marine animals like dolphins do this. Dogs don't do this. They think it's another dog behind the glass and they try and find out where it's coming from. But yes, birds, we think some birds certainly do have this ability to recognise themselves and their reflection, and parrots, being very visually well endowed, probably can too.
And that's unfortunately where we have to wrap up our engagement with Dr. Chris Smith, lecturer at the University of Cambridge, our very own naked scientist, weekly just after 9:30, right here on Views and News.